My name is Kira Bain, and today we are going to be learning about the empirical rule, what it is, its major components, and how we can apply it to a real-life scenario. Let's begin. First, let's look at the empirical rule. So the empirical rule, we have this distribution of data, and we are looking at how the data falls in between these different percentile ranges, and we have 68%, 95%, and 99.7% that are being stretched across this distribution of data, and it's called a normal distribution because it's in a bell-shaped curve. And that is one of the requirements for the empirical rule for it to be able to work. So when data is normally distributed, here we can see we have the data points here, and we have where the data points reach, they start at the bottom here, they start low, they gradually increase in the middle, and then they drop off again at the sides. And this is the normal distribution and a bell-shaped curve, which is necessary for the empirical rule in order for it to be able to work. Let's look at our real-life scenario now and how we can apply the empirical rule to that, and we are also going to be taking apart some of the components of the empirical rule so that it makes sense. So our problem for today states that an employer wants to give gas compensation to his employees and is curious to see what percentages of his employees he can reach at the following values. So 25 to 45 miles, 15 to 55 miles, 5 to 65 miles. And then we're going to be looking at how the 68%, 95%, and 99.7% will apply to these values later on. So we're going to assume a normal distribution because that's the requirement, and we're going to be utilizing the empirical rule, and then it says the mean is 35 miles and with a standard deviation of 10 miles. So first, let's start off with the mean and learn about how that works and what that is, so that way you understand better just what the empirical rule is looking at. So the mean is the sum of all the data points divided by the number of data points. So here, if our data points were 7, 5, and 9, we would add those together, which equals 21, divide them by 3, and we would get 7 as the result. For the standard deviation, if we were to do that in Excel with 7, 5, and 9, we would do equals STD EV, and that would come out to 2. But we are also going to be calculating this by hand, and we have two different formulas for the standard deviation listed here, depending upon whether it is a population or a sample collection of data. So for example, a population of data would be the whole school of Feather River College, while a sample could just be Professor Boffenmeyer's statistics class. And so some of the symbols here vary depending upon whether it's a population of data or a sample of that population. So for the mean for a population, the symbol is mu, and it's X bar for the sample. And then for the standard deviation, for the sample, it is S. And for the standard deviation for the population, it's sigma. And so we can also see the appropriate means placed in the different formulas there. But it works the same way. Let's calculate now the standard deviation for these example data points of 7, 9, and 5, so that you can see just how that works. Calculating the standard deviation for a lot of numbers can be extremely time consuming, so it's best to use technology, but for 3 it won't be too bad. So here we have the 7, 5, and 9 laid out, and we are subtracting the mean, which is 7, from each of those data points, and then we're squaring the data, which is represented by the 2, and then we are adding those together, and then 3 is the end symbol, and that is represented because we have the 3 data points of 7, 5, and 9 minus 1. Here's our formula again here. And so that comes out to 0. This one came out to 1.4142, and this one came out to 2. And then we divide them by 2, and we get the variance, which is 3.4142. And then to get the standard deviation, you would take the square root of that to get 1.85. So the standard deviation is showing us just how far away from the mean we have gone. Here in Excel, we can see with 2, because it's giving us the it's rounding up a little bit, but we can see just because these three numbers are, it's only 3 and they are so close together, how the mean is 7, and so 9 is just 2 away from the mean, and 5 is also just 2 away from the mean, and that's what the standard deviation is it's showing just how far from the mean you have gone. But when you have a large number of data points, it's harder to see what the standard deviation is, unlike for these 3 here. And so that's why you need the formula to be able to calculate it more clearly, and then also you get the more exact number, like we got the 1.85 for the standard deviation. All right, let's go back to our problem now, and we are now going to be utilizing the empirical rule with our problem now that we understand what the standard deviation is and what the mean is. So the employer wants to give his employees gas compensation at the following different mileages. We have the 25 to 45 miles, the 15 to 55 mile point, and the 5 to 65 miles. So we have the normal distribution. We're going to be utilizing the empirical rule, and the mean is 35 with a standard deviation of 10. So the mean would go right here by mu, and that would be the 35. So we're going to go ahead and put 35 right there. And then for one standard deviation away from the mean, we would be subtracting 10, which is the standard deviation, but we would also be adding 10, because you see the 68% for one standard deviation of the mean is on both sides of the mean. So the 68% goes from here to here. So we subtract 10, and then we also add 10 to get the range of 25 to 45. So 25 to 45 miles is 68% of his employees would be driving 25 to 45 miles to work. Next, for 2 standard deviations of the mean, we would be subtracting another 10, or a total of 20 from 35, and then adding a total of 20, or 10 plus 10 to 35. And so we would be getting 55, and we would be getting 35, and that's 2 standard deviations away from the mean. And that's encompassing 95% of his employees now. And so that's reaching across from here to here on our normal distribution. So 15 to 55 miles. So 35 minus 20 is 15. Sorry, I had written 35 there. And then we also have 35 plus 20, which is 55. And that encompasses 90. All right, lastly, let's look at the third standard deviation and how to calculate that. So for the third one here of 99.7%, we're going to subtract 10 3 times. So let's go ahead and subtract another 10 here. And that comes out 35 minus 30 would be 5. And then we're going to add 10 3 times, so let's add another 10 here, and 35 plus 30 would be 65, or 35 plus 1 standard deviation plus 2 standard deviations plus 3 standard deviations, and then 35 minus 1 standard deviation minus 2 standard deviations minus 3 standard deviations. And that is how we calculate to see how these different mileages would fall into these different percentile ranges. So 5 to 65 miles would be falling into 99.7% in the empirical rule, and that's how many of his employees it would be encompassing. So it would only leave a very small fraction of employees out of his gas compensation plan if he were to have an outlier somewhere way off, like maybe in the 80s here, if the highest his plan is going to go is to 65 miles. So today we looked at the empirical rule. We looked at how we can utilize it in a real-life scenario. We looked at some of its major components and how to calculate them, like the mean and the standard deviation. And also we looked at the difference between the population and the sample mean and standard deviation symbols. We also looked at how we can utilize the empirical rule and the empirical rule's percentage values in a real life scenario. Thank you so much, and I hope you enjoyed learning about the empirical rule today with me.